So the first one has a negative in it. That's your even or odd. So the even ones turn positive, the odd ones turn negative. So like the $1 million question there is secant even or odd? I know it's like one or the other, right? Secant is even. What's the other even one? Cosine. Okay, so the even ones turn positive, and so it's just going to be secant of x. These all have x in them instead of theta. It could really be like any letter of the alphabet. All right, so look at this one. 1 plus tangent squared. I have it up there on the board, and you guys have it on your paper too. What would 1 plus tangent squared get replaced with? Secant squared. Good. I think I made these first few just like you can basically answer it. All right, sine over tangent. Now we're going to have to do a replacement there. I'm going to rewrite sine just as sine over 1 and then draw a really big fraction bar. What can you replace tangent with so that it has sines and cosines? You want to turn everything into sines and cosines if you can. Okay. Sine over cosine. So again, it's replacements. It's like doing a little puzzle. You're like, what can I replace this with? So you have a fraction and then a fraction bar and then another fraction. What you do is you keep the top one the same. So just keep that sine of x over 1. Change it to multiplication and then do what? Flip it. We're going to multiply by the reciprocal. So you're just going to flip this over. So it'll be cosine over sine. Divide by a fraction means multiply by the reciprocal. And then you want to look for something to cancel. That like simplify means something should cancel. So what's going to go away? Yeah, the signs go away. You have cosine over 1, which is just cosine. So for this one, we have a subtraction. When you have adding or subtracting, you need to turn them both into fractions and then get a common denominator. That's the idea, is you don't want two separate things. You want to put them together. So what could I replace secant with that involves either a sine or a cosine and has, a fraction in it? 1 over cosine. Perfect. Awesome. You guys are with me here. Minus, and then tangent would be sine over cosine. So actually, that's an easier problem because what's the common denominator? Yeah, they already have a common denominator. You can just like smush them together. Smush is a very technical. Yeah, 1 minus sine over cosine. And you might be like, how does that look better than what we started with? And that's a really, really valid question. The only thing I will say is instead of 2 separate items, you now have 1, and that's how it's technically better. Yep, but that's it for that. All right, so again, you want to replace with sines and cosines. So we have cosine, great, just keep that the same. You can put it over 1 if that makes you happy. A lot of times that helps to put the little ones in there. And then we have cosecant. So what can I replace a cosecant with? 1 over sine, good. So we've got that. Huge fraction bar. And then what can I replace cotangent? Cosine. Gosh, you guys feels like you know them already. That was really good. So kind of look through that. I know, that's the correct response there. You have cosine over sine over cosine over sine. Do you remember when we did unit circle and we had square root of 2 over 2 over square root of 2 over 2? It's really similar to that. Anything over itself is 1. This whole thing is 1, which is kind of neat. I kind of like when it comes out to just a number that kind of is satisfying. All right, when you see the whole thing squared like that, it means you have to write it twice. It's a twin. So yes, that's a little bit of writing, but you'll be okay. And then you distribute all that to each other. So I will point to it and talk you through it. 1 times 1 is 1. So the outsides will give you -1 sine. The insides will give you -1 sine. So together, get -2 sine of x. And then when you multiply the last, first of all, yeah, sine squared, good. And why is it positive? Negatives cancel. All right, cool. You guys are making my life easy. I don't even have to explain it. You guys are like, we got it. All right, this is one of the co-functions. When you see a negative, it's even or odd. When you see that 90 minus, it's co-function. You just add or remove a co, so it's sine. Good. I don't know that this has ever gone so well before. This is like going very, very well. Usually people like dig in their heels and want to fight me on this topic because it is kind of no fun, you know? You guys have got it. All right, so here we have sine, and I'm going to write it over 1. Again, a lot of times that's helpful if you put it over 1. What can we replace cosecant with? Yeah, 1 over sine, perfect, minus, and I'm just going to leave that as cosine squared. You want to turn everything into sines and cosines. So if it's already a cosine, probably just leave it alone. Where can we go from there? Like what? Sines cancel, so you have 1 minus cosine squared. This is one of the Pythagorean ones. Good, so if you subtract over this cosine squared, 1 minus cosine squared is sine squared. Awesome. All right, this one, very similar to what we did in number 6, where we distribute all this stuff to each other. It's already set up for us. So when you multiply the first, cosecant times cosecant, cosecant squared, yeah. Now, instead of them both being negative, like it was up here, we have 1 positive and 1 negative. So when you do the outsides, you get -1 cosecant. And when you do the insides, you get +1 cosecant. So they're canceled, they're gone. Just do the last. 1 times -1 is -1. And then again, that's a Pythagorean one. If you have cosecant squared minus 1, cotangent squared. Cotangent squared. All right, and then last one. First thing I'm going to do is turn it all into sines and cosines. I'm going to start over here. I'm remembering this one being a little bit longer, which is kind of a bummer because it's sort of close to the bottom of the page. I'm going to leave sine alone, but I am going to put it over 1. Again, lots of times that's helpful. Plus, and then what can we replace cotangent? Cosine over sine. And then I'm going to leave cosine alone, but again, I'm going to put it over 1. Again, lots of times it's helpful to just put it over 1. So we have 2 separate items here separated with a plus sign. I need to get a common denominator. So your common denominator is going to be sine. So this one's already good. This one I'm going to have to multiply by sine. And actually, I'm already seeing where this goes and it won't be too bad. Sine times sine, sine squared, good, perfect, plus cosine times cosine is cosine squared. And are you already seeing like where we're going to go with that? Over your common denominator. Yeah, it's sine squared plus cosine squared in the numerator. We had sine times sine is sine squared, cosine times cosine is cosine squared, and then that's all over our common denominator, which was sine. Well, it's a common denominator, so it just goes over that. Like, where was the other one that we did? This one, do you see how the common denominator was cosine? So the whole thing just goes over cosine. Just goes over. Think of like, do you remember back when math was just numbers? Like back in the good old days. Do you remember if you had like 1/3 plus 1/3, it would be 2/3? Like the thirds would just stay thirds. It's like that. Like it's just over whatever your common denominator is, it's just over that. Oh, you cannot cancel those. Good, that's where we're headed. Why is the top equal 1? Pythagorean, good. And then 1 over sine is cosecant. Good. Do you guys understand why way back when I started teaching this to you, I really pressured you to say them correctly? Like, because if you say cot or tan or like, then it's not going to make sense to you, especially the co-function ones. You have to say them correctly.